Hello, 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 hello. Yes, guys, I hope so. I'm perfectly audible and visible to all of you. हाँ जी, अ, आवाज आ रही है सभी को? हेलो 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 हेलो, चेक 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 चेक. Yes, guys. All right. So 5 people are waiting, I believe, for this particular session, right? As I can see, and I hope so. I'm perfectly audible and visible to all of you. Please let me know in the chat section. Hello, hello, hello. Yes, guys. Okay, I can see the smiling faces in the chat section. Okay. Yes. How are you, guys? I hope so. I'm perfectly audible and visible to all of you. है ना? Again, we are back with our series of previous year paper discussion, and good to see a lot many people had joined on time today, right? Okay. So hello everyone, my name is Kunal Gupta and I welcome you all to PW Gulf. चाय भी लो कहीं से स्वाद मिलेगा यही से. Drink tea from anywhere, but you will get taste only from here. And to have the taste, we are starting with the lecture number 5 of our lecture number 6 of our previous year paper discussion series, which we started around 2 weeks back, right? And last week we could not have the regular sessions because I was sick, right? But now, as I said, this week we would be having at least 5 such sessions. Those who had joined late, right, or not aware of what's going on in this particular session or what this channel is about, let me just quickly brief it to you. Fine. So, by the way, this handsome guy in the photo, it's me only. So, please do not get confused. Don't go on the hairstyle. It's too hot here, so I just got a hairstyle recently only. All right. So basically, this previous year paper discussion series, okay. So you are here onto PW Gulf YouTube channel, okay, which caters the need for JEE NEET and even boards in the Gulf region, right? Students preparing in the Middle East, yes, but students from India also do join. So here we are running a series for physics because physics is expected to be very tough for the re-NEET, which is happening on 21st of June. Okay, re-NEET 2026. Here we had started 2 series. One is the most important question series. You can find 3-4 lectures on the. You have to go on the PW Gulf YouTube channel. Click on the live section. There you will find it. Okay. Second series we had started previous year paper discussion series. See, it is very important. है ना? From 2005 to 2026 we are going to discuss. है ना? What I will do is one day I'm going to keep it where we can discuss 4-5 papers. So don't worry, we will be able to complete them on time. You just watch out the exam conducted on 3rd of May. It has a lot many questions which were asked earlier, है ना? 20 years back, 15 years back, they were there. Fine. So here also I will just show you the questions which were asked this year or the previous year. Fine. So nothing can like last 20 years, है ना? 45-50 questions we are practicing, है ना? So almost more than 1000 questions we are gonna practice, है ना? So there cannot be anything beyond these 1000 questions, है ना? So best series. So the duration would be, we had already discussed 2005, 6, 7, 8, 9, है ना? Today we are gonna discuss 2010 paper. Earlier the name was not NEET, it was All India Pre-Medical Test. Okay. Then the name got changed to NEET. Fine. So in 2010 it was All India Pre-Medical Test, and there used to be prelims and mains. Like you have the JEE mains and JEE advance. Here you used to have it prelims and mains. So both paper we are going to discuss, and mains has some very good questions, very much enough for your practice. Okay. Fine. Then when NEET comes up, we are going to discuss NEET only. Okay. AIMS used to have a separate exam earlier. Okay. They used to have their own exam. Okay. So 30 seconds I will give you to read the question. Read it. Make sure you subscribe the PW Gulf YouTube channel and hit the like button. है ना? Subscribe the PW Gulf YouTube channel so you will get the notification when the new lecture is coming, and hit the like button of the stream. Okay. चलिए let us begin. The dimension of 1 by 2 epsilon naught E square, where epsilon naught is permittivity and of free space and E is the electric field. See, no need to just write down the dimensional formula for this and this. No. 1 by epsilon naught E square is nothing but energy density. That is nothing but energy per unit volume. Energy per unit volume. Energy is ml squared T raised to the power minus 2. Volume is L cube. This gets cancelled out. M L minus 1 T raised to the power minus 2. M L minus 1 T raised to the power minus 2. Option number 3. Next question. This is a good one. Motion in a straight line. Yes. Hi Saptrishi, how are you? Fine. Okay, if you want me to teach in English also, please let me know. Okay, I'm gonna explain you in Hindi or English as well. Fine. Make sure you subscribe the channel and hit the like button. Okay. A particle moves a distance x in time t according to the equation this. The acceleration of the particle is proportional to what? This was a good question. Most of the people were not able to get to the answer. X is equal to t plus 5 raised to the power minus 1. The position is written in terms of time. Differentiate this with respect to time. I hope you know what is the differentiation for x raised to the power n. Power comes up here, power comes here. X raised to the power n minus 1. Minus 1 comes up here. Subtract 1 from the power. This will become minus 2. Fine. And again, if you have to apply the chain rule, you can, but you will get 1 only. Fine. Velocity, you are getting it as minus 1 t plus 5 raised to the power minus 2. Again, differentiate this with respect to time. You will get acceleration. Hai na? So minus 2 comes up here. T plus 5 as it is. Again, subtract 1 from the power. 2 t plus 5 raised to the power minus 3. This is acceleration, not v. So you had got acceleration as this much. Now you have to write acceleration either in terms of distance or in terms of velocity. Okay. See, x to was t distance, it was t plus 5 raised to the power minus 1. Hai na? Okay. So clearly it won't be related directly to distance, and to distance you can just omit from the options, but anyways I will explain it. Okay. Again, you have to write acceleration in terms of velocity or in terms of distance x. Now, got it? So what I can do is that I can just get the value of t plus 5 from here. Squaring both sides. Magnitude of velocity, you get it as t plus 5 raised to the power minus 2. Okay. You can take root both sides. V raised to the power 1 by 2 t plus 5 raised to the power 1 by 2. Okay. In fact, minus also you can put so that this becomes plus. V raised to the power minus 1 by 2 is t plus 5. Fine. Okay. Now here you can just substitute it. Acceleration is equal to 2. Instead of t plus 5, you can just write v raised to the power minus 1 by 2. ये क्या था? Bhar already minus 3 is there. Acceleration, you will be minus will become plus, directly proportional to v raised to the power 3 by 2. Is this in the option? Velocity raised to the power 3 by 2? Yes, option number 2. Fine. Clear? Any doubt, any query? Fine. So this was a slightly tough because you have to find the acceleration in terms of velocity or distance. Achha, today we are having a lot many questions. Okay. So we would be running a bit fast. Quick. 30 seconds. to read the questions. Six vectors A through F have the magnitude and directions indicated in the figure. Which of the following statements is true? Okay. So vector F basically is represented by which of the two? Okay. So vector F is in this direction. Now see, a broad idea you should get. Okay. If vector F is in this direction, so all other vectors, they are vertically, either vertically or horizontally. So vector F would have been logically formed by these two vectors. Any vector, one in this direction, another in this direction, plus j cap minus I cap. Only then you can get vector F, correct? Now see the vector, those vectors which are in these directions. Here vector E is in this direction, vector D is in this direction. So F is equal to D plus E. Yes. A particle has initial velocity this much and acceleration this much. The speed after 10 seconds. So direct V is equal to U plus AT. V is equal to U plus AT. V is equal to U is how much? 3I cap plus 4J cap. Plus acceleration is 0.4 I cap plus 0.3 J cap. Time is 10. 3 I cap plus 4 J cap plus 4 I cap plus 3 J cap. 3 plus 4 7 I cap plus 7 J cap. Okay. Magnitude of velocity will be what? Under root 7 square plus 7 square. Okay. 7 root 2. Option number 3. Fine. Too direct. है ना? अच्छा, wherever I feel that yes. Okay. अच्छा, mains questions are quite tough. This is again a good one. है ना? Again I am saying I will show you the mains question also. है ना? कहाँ है? Let me just show it to you. So approximately 80 questions we have to do today. Yeah. Mains के बढ़िया सवाल आते हैं. A block of mass m is in contact with a cart C as shown in the figure. The coefficient of static friction between block and cart is mu. The acceleration alpha of the cart that will prevent the block from falling. ठीक है, तो acceleration निकालनी है. ठीक है, that will prevent the block from falling. Which of the following options would be correct? Now see, this block would have fallen because of its weight, but frictional force would have balanced it. Fine, this would have fallen because of the weight. So definitely frictional force would have been greater than equal to mg. Correct? Now, just sit on this block. Sit on this block. Imagine that you are sitting on this. आप बैठे हुए इस पे. So a pseudo force would be acting, which will be equal to mass into acceleration. Mass into acceleration is alpha. Okay, and a normal to of course is acting. So normal is balanced by ma or m alpha. Frictional force is mu into n. Normal force is how much? M alpha. M से m gets cancelled out. Alpha must be greater than equal to g by mu. G by mu. Option number 4. Marks se marks kariye na, yes. Fine, clear? Any doubt, any query? A good one. A similar question was asked again. Achha, this is important. Now, what it is saying in the question, this is a good one. A 50 kg mass a man of 50 kg mass is standing in gravity free space. That means there won't be any weight acting. Gravity is free space. G is equal to 0. Weight is 0. है ना? At a height of 10 meter above the ground. ठीक है, तो this is right now at a height of 10 meter. Very good. He throws a stone of 0.5 kg mass downwards. ठीक है, तो he had a stone with him of 0.5 kg. ठीक है, fine. He had a stone with him of 0.5 kg, throws downward with a speed of 2 meter per second. है ना? When the stone reaches the floor, the distance of the man above the floor will be. What would be the distance of the man above the floor? देखिए, this is the initial condition. What will be the final condition? He has thrown a stone, है ना? With some speed he has thrown. ठीक है. Now here what will happen? It's a gravity free space. It's a question from motion of center of mass. And see, initially both of them are at this position. They are at rest, है ना? They are not moving, है ना? Center of mass is also at rest, है ना? Afterwards you had thrown the stone. What will happen? This person, he's gonna shift upward. He's gonna shift upward. That's why distance from the ground will change, and they are asking when the stone reaches the floor, the distance of the man above the floor will be. Fine. So this man also should shift upwards as the stone reaches downwards. So can I apply delta RCOM is equal to M1 delta R1 plus M2 delta R2 divided by M1 plus M2. Now this delta RCOM, है ना? Initially center of mass was, let us suppose here. So afterwards also center of mass will remain at its own position because there is no external force applied, है ना? F external is equal to 0. RCOM becomes 0. So M1 delta R1 plus M2 delta R2. ठीक है, ये निकालना है. तो delta R2 is equal to M1 delta R1 by M2. माइनस लगाते थे. ठीक है, मैन को लेट अस सपोज दिस इज मास M1, मैन को आई एम अज्यूमिंग मास M2, है ना? तो 0.5 kg मींस 1/2. अच्छा, दिस स्टोन हैज मूव्ड अ डिस्टेंस ऑफ 10 मीटर्स. ठीक है, एंड मास ऑफ दिस पर्सन इज 50 kg. M1 is 1/2, 0.5 kg is 1/2. And how much this stone has moved? 10 meters. M2 is 50 kg. Minus 0.1 meter. So delta R2 is minus 0.1 meter. So this has shifted, minus is indicating opposite direction. So this has shifted 0.1 meter further, है ना? So let us suppose he has reached here. So now the new distance will be 10 plus 0.1 from the ground. 10 plus 0.1, that is 10.1 meter. Is this in the option? Yes, option number 3. Very good question. Classy question. How much time should it need to get completed while solving a question from a new topic? Okay. See, Kundan, first of all, you should not pick a new topic as of now. ठीक है. Try to practice and revise as much you can. ठीक है. Right now, what will save you? Revision. ठीक है. Revision. As much as you can. Question practice is happening here. Pause the video and try it out. Pause the video and try it out. है ना? ठीक है. Now NEET also has a limited set of questions ना, है ना? कुछ भी they are not gonna make. JEE advanced के question थोड़ी डाल देगा इसमें, है ना? Again, this is good one. An engine pumps water through a hose pipe. Okay. An engine pumps water through hose pipe. Very good. Water passes through the pipe and leaves it with a velocity of 2 meter per second. The mass per unit length of the pipe is 100 kg per meter. Okay, 100 kg per meter. It is leaving with a speed of 2 meter per second. What is the power of the engine? Power is F dot V. Now what is force? Force is equal to delta P by delta T. Change in momentum, final momentum minus initial. Initial, it would be 0. Mass can be written as density into volume. Mass can be written as density into volume. Volume can be written as area into the length. For example, what is the volume of this? Area into this length. Fine. This is how we write. Volume can be written as area into length. This L by T is nothing but the velocity only. This becomes rho A V square. Rho A V square. Fine. Now density can be written as again mass per unit volume. Volume is area into length. Area gets cancelled out. Okay. M by L. M by L is nothing but mu only. So mu V square. Can I substitute here? F into V. F is how much? Mu V square into V. So power you would be getting it as mu into V cube. Mu is how much? 100 V cube. 2 ka cube. 2 to 4, 4 to 8. So power you would be getting it as 800 watt. Option number 1. So this was a good question. Fine. Clear? Clear? Any doubt, any query? No. Yes. Tell me. Whenever collision happens, there is one general formula. Hanji, please tell me the formula in the chat section. Hanji, Saptarishi, King, whosoever is there. I don't know why I'm waving my hairs. There are no hairs at all. Oh, a ball is moving with velocity 2 meter per second. Okay. So U1 is given to you as 2 meter per second. Collides head on with another stationary ball. So U2 is 0 meter per second. Okay. Of double the mass. Okay. If the coefficient of restitution is 0.5, then their velocities after collision will be. I hope you are aware what are the velocities after collision. So how do you write? M1 plus M2 you used to write like this. Plus M1 plus M2. M1 plus M2, U1 and U2 comes here. E, this is 1 here, so you have to write 2 here. This is 1 here, so you have to write 2 here. So this was the V1, okay. Coefficient of restitution is 0.5. Coefficient of restitution is 0.5. So V1 I would be getting it as. Okay, so M1 is M and M2 is 2M. Okay. So M plus 2M, 3M you get. M plus 2M into 2, 0. Coefficient of restitution 0.5 or 1 by 2. M2 is how much? 2M. U2 minus U1. 0 minus 2 minus 2. 2M upon 3M. 2 and 2 gets cancelled out. M and M gets cancelled out. Minus 2 by 3. Okay, so V1 you would be getting it as 0 meter. Fine. Acha, okay. V2 also you can calculate, but I think you can just apply conservation of momentum. M1 U1 plus M2 U2. is equal to m1 v1 plus m2 v2, है ना. So this is zero factor because this is 0. Again v1 is 0, so this becomes 0. So m1 into u1, है ना, 2 into m. m2 is how much? Again 2m into v2, है ना. 2m 2m gets cancelled out. So v2 you will be getting it as 1 meter per second. 0, comma. See, you can apply the formula for v2 also. No problem with that. You are gonna get it as 1 only. But conservation of momentum was a bit easy for me to apply. So immediately I had applied here. Pause the video and try it yourself. Pause the video and try it yourself. अच्छा, gramophones were used earlier, है ना. Okay, Anji. So they are saying a gramophone record is revolving with an angular speed omega. Okay. A coin is placed at a distance small r from the center of the record. The static coefficient of friction is mu. The coin will revolve with the record if which of the following condition is satisfied. Similar to that friction one. Similar to that friction one. The previous question. So let us suppose you had placed a coin. Which is at a distance small r. So imagine a centrifugal force is acting, mr omega square. A frictional force would also be acting, mu into n. Okay. So this frictional force must be greater than my centrifugal force, है ना? That is mu into n, here mu mg. mr omega square. M से M gets cancelled out. Mu g by omega square is greater than r. Fine. Clear? Any doubt, any query? Acha, please make sure you hit the like button of the stream and subscribe to PW Gulf YouTube channel so that you get all the updates what is going to happen in the session, and share the link with your friends who are preparing for NEET exam because it takes a lot efforts, है ना. This is important and it is lengthy at the same time. If it comes in your exam, just leave it at the moment. If at the end you are left with time, only then attempt it, है ना. Leave it. By chance if you learn the answer today and it comes as it is, so then it is fine, but otherwise you won't be able to solve it on time. Now, a circular disk of moment of inertia, IT is rotating in a horizontal plane about symmetry axis with a constant angular speed omega है ना. ठीक है. तो ओमेगा आई मोमेंट ऑफ इनर्शिया आई टी, है ना. ठीक है. अनदर डिस्क ऑफ मोमेंट ऑफ इनर्शिया आई बी is dropped coaxially with the rotating disk. So there is another disk which is just dropped above this, ठीक है, of moment of inertia IP. IT तो was already there. Now IB is also there into the picture. ठीक है. Over the rotation. Initially the second disk has zero angular speed. Eventually both the disks rotate with constant angular speed of omega f. Okay. The energy lost by the initial rotating disk to due to friction is, you know. Now they are not asking you the moment of inertia or angular momentum, nothing. They are asking how much is the energy lost. See, the approach would be whatever is the kinetic energy initial and whatever is the kinetic energy final. Now, you will be getting energy lost by subtracting them. Okay. But the thing is that it's too lengthy to find the how much will be the final kinetic energy and all that thing. Reason being, देखिए, because you need the value of omega f in terms of omega I. Okay. Now you can apply conservation of angular momentum. You can definitely you can definitely apply conservation of angular momentum, है ना. L1 is equal to L2. I1 omega 1 is equal to I2 omega 2. So it is IT here rotating with the speed of omega I. Final moment of inertia IB plus IT. Omega 2 is how much? Omega F. Okay, fine. So omega F you would be getting it as how much? IT into omega I upon IB plus IT. ये आ गया omega F. In terms of omega I. Fine. Now, how you will be finding initial kinetic energy? Let me just add one page. Initial kinetic energy will be half initial angular momentum upon initial angular speed. So half I1 is how much? IT omega initial square. What will be final kinetic energy? Half I1 half I2, that is IT plus IB. IT plus IB ओमेगा फाइनल का स्क्वायर हाफ IT प्लस IB ओमेगा फाइनल का स्क्वायर. Omega final ka square. Now you need to square this and substitute there. That's why I was saying you have to avoid this question because it becomes very lengthy. IT upon IB plus IT whole square is there, है ना. चलिए square of numerator and square of denominator omega initial का square है ना. So one of this तो will get cancel out है ना. Now you can just do KF minus KI. आप मैं कॉमन ले लेता हूँ. हाफ चलो जो मर्जी के आई माइनस के एफ भी कर सकते हैं. हाफ आई टी ओमेगा आई का स्क्वायर माइनस हाफ आई टी का स्क्वायर अपॉन आई बी प्लस आई टी इंटू ओमेगा आई का स्क्वायर. ठीक है, क्या क्या आ रहा है ऑप्शन में? देखिए हाफ तो नो हाफ इज नॉट देयर इन दिस ऑप्शन, सो दिस ऑप्शन तो विल डेफिनेटली बी गेट एलिमिनेटेड, है ना. चलिए तो वॉट एवर इज कमिंग कॉमन टेक आउट कॉमन, है ना. हाफ आई टी आई कैन टेक कॉमन फ्रॉम हियर, ओमेगा इनिशियल का स्क्वायर आई कैन टेक कॉमन फ्रॉम हियर ना. ये तो पूरा ही बाहर आ जाएगा. हाफ आई टी ओमेगा इनिशियल होल का स्क्वायर 1 माइनस आई टी upon IB plus IT. Half IT omega initial whole square. Send this here. IT will get cancelled out. IB upon IB plus IT. बन गया. Yes. Got the answer. Half IB into IT. ओमेगा इनिशियल का स्क्वायर अपॉन IB plus IT. Fine. Is this in the option? Half IB into IT omega initial का स्क्वायर upon IB plus IT. Fine. Such a good question it was. Fine if it comes as it is and you do remember the answer ki sir has got this as the answer, so you can just memorize it and quickly mark it, but in exam you won't be able to solve it. Just leave this question and move to the next. Two particles initially at rest. External force is equal to 0. So whatever was initial velocity of center of mass will be final velocity. Initially they are at rest. So finally also the center of mass initially is at rest. So finally also it will be at rest. Okay. Anji, what is the orbital speed of a satellite? What is the orbital speed of a satellite? Hello, 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 hello. Anji, suppose here is our planet and there is a satellite which is revolving around. Okay. So orbital speed is given by under root gm by r. They are saying the radii of circular orbit of two satellites A and B of Earth are 4r and r respectively. Okay. If the speed of the satellite A is 3v, then the speed of the satellite B will be. So this speed is inversely proportional. G and M to will not change. So this is inversely proportional to r. So v1 by v2 under root r2 by r1. Satellite A, it is how much? Satellite A means 1 only. It is 3v. Okay. Satellite A का radius it is 4r. And the दूसरे वाले का radius it is r. R and r gets cancelled out. 3b by v2 is equal to 1 by 2. Send it here. So v2 you would be getting it as 3 into 6, 3 into 2, 6v. Fine, clear? Any doubt, any query? You guys can unmute and ask. चलिए. Again, one more question. अच्छा, okay, ये तो दूसरा. अच्छा, okay. I hope you are aware what is the gravitational potential due to a spherical shell. A particle of mass m is situated at the center of a spherical shell of same mass and radius a. Okay. The gravitational potential at a distance a by 2 from the center. Okay. You should know, suppose here is a shell. Okay. So the gravitational potential due to this shell is given by minus gm by whatever is the distance. Okay. If it is on the surface, it becomes minus gm by capital R. If there is, it's on any point inside, it remains same, minus gm by R. Right? So you should memorize this. Now they are saying that a particle of mass m is situated at the center of the shell. And of same mass, the shell of same mass, ठीक है, mass same है, and radius a, है ना, the radius of this is small है, ठीक है, mass of the shell is also 1, ठीक है, the gravitational potential at a point situated at a distance a by 2, है ना, suppose here is the point which is at a distance a by 2. What is the gravitational potential? है ना? So at this point P, gravitational potential will be due to the point mass and will be due to the spherical shell. Due to the point mass, it is gm by a by 2, है ना? Because it is at a distance a by 2 from this mass. Now this point P is lying inside this shell. So there will be some potential due to the shell also, है ना? तो वो shell की वजह से भी potential आएगा. Fine. Make sure guys you hit the like button of the stream and share it with your friends. So shell की वजह से it would be minus gm because for the shell this is the point inside. So inside it is equal to the radius only, है ना? Minus 2 gm by small a minus gm by small a. Now minus minus becomes plus, minus 3 gm by small a. Option number 2. Fine. Option number 2. This is also a good one, important. See, from mechanics a lot many questions used to come. There was a time majority of the paper was from there. Okay. Ball is dropped from higher rise platform at time is equal to 0 starting from rest. Okay. So there is a high rise platform. Imagine you are standing on the roof of this high rise platform. छत पे खड़े हुए, बुर्ज खलीफा की छत, ठीक है. very high rise. Now, you had dropped at time is equal to 0. Dropped means initial velocity is 0. At time is equal to 0. U is equal to 0. Okay. Starting from rest. After 6 seconds, another ball is thrown downwards from the same platform with a speed v. Okay. After 6 seconds, मतलब either say you had thrown it, but I am drawing it a bit farther so that you guys can imagine. है ना? Either say you had thrown this second ball. After 6 seconds, है ना? After 6 seconds, ठीक है. Both the balls meet at 18 seconds. So you had started the timer from here, है ना? After 18 seconds, you had thrown it with some speed v, na? Your initial speed is not 0. You had thrown it with some initial speed v, hai na? And see, this will move. You had thrown it earlier because so this will cover some distance, hai na? Already it would have covered some distance. Now you have to give it some velocity to reach there, hai na? So time is running, and after 18 seconds, starting from here, both meet. So basically, this ball has traveled for 18 seconds, and this ball, since it has been dropped after 6 seconds, so this travels for 12 seconds. I hope you are able to get it. And both of them, let us suppose, met here. So at the same time they had met. At the same point they had met. Fine. What is the value of V is what they are asking. See, one thing though is for sure. Since they are meeting at a point, they are thrown from the same point. So whatever distance it has covered is covered by this also. Fine. S1 is equal to S2. So U1T plus half G T1 का square. U2 T2 plus half G T2 का square. So initial speed is 0, है ना? So this becomes 0. Half G T1 means how much? 18 का square. अच्छा, U2 is V, है ना? V into T2 is how much? 12 seconds. Plus half G is how much? अच्छा, G को G ही रहने देते. 12 का square. Fine. Let us bring it here. So half G, when I bring it here, so this will be subtracted, half G will come common. 18 square minus 12 square. 12V. G is equal to 10, so this will become 5. 320, 18 square is how much? 19 is 361, 324. 324 minus 144 is equal to 12V. 344, 150, 150, 175, 175 plus 40. अरे सीधे सीधे ऐसे ही लेते हैं, क्यों स्किल दिखाना. 12 में से 4, 8, 2, 1, 180. 5 into 180 is equal to 12V. So 6 it goes on 2, 6 it goes on 30, again 15. So V finally you would be getting 15 into 5, 75 meter per second. Option number 2. Fine. Clear? Any doubt, any query? Please let me know in the chat section. We are running this series from 2005 to 2026 for the NEET 2026, and that is happening on 21st of June. Today we are discussing the paper of 2010 AIPMT, pre and mains both. Pre mains dono discuss ho gayi. A cylindrical metal rod in thermal contact with two reservoirs of heat at its two ends conduct an amount of heat in Q time. किस पे पहुंच गए 18? Okay, we need to hurry up, है ना. The metallic rod is melted and the material is formed into a rod of half the radius of the original rod. ठीक है, half the radius तो ठीक है. What is the amount of heat conducted by the new rod? Length will increase when placed in thermal contact with the two reservoirs. Half the radius बोला है. So let us suppose here was the rod. It got melted into half the radius. It got melted into half the radius. Okay. Suppose the radius is r here, so this becomes r by 2. So area A1, let us suppose it is A, which is pi r square. Area 2 will be how much? Pi r square by 4. This will become, or you can simply write A by 4. A by 4. Fine. Suppose the length was L here. Suppose the length was L here. Suppose the length was L here. So you must know that the volume remains constant. Whatever the volume was here must be here. So what will happen? So here the length, area has become A by 4. So length will become 4L. Length will become 4L. Okay. Now it is done. Q is equal to, Q by T is equal to sigma A T raised to the power 4. अरे क्या लिख रहा हूँ ये? Sorry. Thermal conductivity का लिखना है ना. Rate of heat transfer, it is given by Ka delta T by L, है ना? Ka delta T by L. Now, since it's the same material, K remains constant and it is kept across the same temperatures, है ना? तो delta T will remain fixed, है ना? Delta T will remain fixed, है ना? Delta T will be constant. है ना? So here delta T will remain constant, है ना? That is same across both the lengths. Okay, so just I can write for the same time T they are saying, so I'm just writing it as small t, है ना? So Q is proportional to, directly proportional to A and inversely proportional to length, है ना? So I can just write Q2 by Q1 or Q1 by Q2 also you can write, है ना? A2 by L2, A1 by L1, है ना? Okay. Q2 by Q1 is how much? Capital Q only, and they are saying that of heat Q in time T. A2 is how much? A by 4. L1 is L only, L2 is how much? Again L by 4L. Okay. A1 is how much? Capital A. So AL gets cancelled out. 1 by 16 you are getting, so Q2 from here you will be getting it as 1 by 16 times Q1. Option number 3. Clear? Any doubt, any query, you guys can unmute and I'm sorry, you guys can type in the chat section and ask. Clear? Fine. Hello, can you hear me? Okay, okay. Sorry. आवाज तो आ ही रही होगी ना, माइक ऑन है, आई होप सो. अच्छा, ये क्वेश्चन वी हैड ऑलरेडी डन, है ना? What is the power? Suppose there is a body at some temperature T, है ना? So what is the rate of emission of heat, है ना? Or simply power, that is given by sigma into A into T raised to the power 4. By the distance r from a center of a star of radius r, है ना? Suppose this star was of radius small r, so 4 pi small r square into T raised to the power 4. Now imagine you had drawn a sphere around it. Imagine, है ना, एक सरफेस के अंदर ये स्टार रखा हुआ है. Okay, what is this power? What is this power received by a unit area. What is the power received by the unit area? So what you will do, you will divide this by the area of this dotted circle. That will be 4 pi capital R square. है ना, तो 4 pi से 4 pi gets cancel हो, sigma R square upon capital R square into t raised to the power 4. Sigma R square into capital R square by t raised to the. Fine. Clear? Any doubt, any query? This is important one because they had asked this similar question I think in 2007 or 8. Same question. अरे भाई ये तो आप आसानी से कर लोगे. Answer this. 30 seconds for you to solve. हाँ जी, yes. Hello. I hope so I'm audible. By the age of this dotted circle. Hello. हाँ जी, done. Yes. अच्छा, those who had joined late, please hit the like button and share the link of this video with your friends who are giving the NEET exam again. Fine. Let me know if you want me to speak in English or Hindi so that I get idea of my majority of the audience. Where are they? The displacement of a particle along x-axis is given by this. The motion of the particle corresponds to. Oh. Okay. So they are saying that the displacement of the particle along x-axis is given by x is equal to a sine square omega t. First, you need to tell whether it is an SHM or not, because there is an option. It's not a simple harmonic motion also. Fine. ठीक है. चलो, let us see. Now first, you should attempt to remove this square. How you are gonna do that? Cos 2 theta is equal to 1 minus 2 sine square theta. 2 sine square theta, 1 minus cos 2 theta. So sine square theta is equal to 1 minus cos 2 theta by 2. Fine. A 1 minus cos 2 omega t by 2. Okay. X is equal to a by 2 minus a by 2 cos 2 omega t. Fine. So if you want, you can send this here. X minus a by 2 is equal to minus a by 2 cos 2 omega t. Is this HSM? You can just represent it by capital X also. This minus a by 2 is nothing, but it just shows that it is not at a mean position at time is equal to 0. Otherwise, yes, this represents an simple harmonic motion. Fine. And what will be the frequency of this? Frequency is 2 pi. Whatever here is the angular frequency, you divide it by 2 pi. 2 से 2 कट गया. Frequency you get it as omega by pi. ठीक है. Now here is the mistake that students do here. है ना, ये t के साथ जितना भी है ना, this entire you put it. I know you had learned the formula omega by omega by 2 pi है ना for frequency. ओमेगा, what is this? Whatever is the coefficient here with t, है ना, मतलब ये cos और t के बीच में है ना, this entire value comes up here. Okay, so this is the major mistake students do here. They just mark this as first one, but answer here. Fine. Pi. Omega by pi. Fine. चलिए. The time period, the period of oscillation of mass m suspended from a spring of negligible mass is t. Okay, fine. If along with it mass m is also suspended, एक minute. Mass m is also suspended, the period of oscillation will be, okay, time period is proportional to the root of mass, है ना? So they are saying that t1 by t2 is equal to root of m1 by m2. No. Initially the time period is t, now t2. Mass initially is m, afterward it becomes 2m. This gets cancelled out. No. So root 2 times option number 1. Clear? 2 direct question, है ना? अच्छा, the session would be of roughly 2 hours, है ना? No, 2.5 hours, है ना? Because we have to discuss the prelims and the mains question both, है ना? So you can just, if you need a break, you can pause the video and go for a break. But session, please attend it wholeheartedly because it is very important. भाई ये क्या है? The transverse wave is represented by this. For what value of the wavelength is the wave velocity? Wave velocity is equal to maximum speed of the particle, है ना? ओ भाई, what is wave velocity? Omega by k. What is the maximum speed of the particle? V is equal to omega under root a square minus x square, है ना? ओमेगा ये हो जाता है. ओमेगा से ओमेगा कट गया. K is nothing but 2 pi by lambda. Lambda is how much? 2 pi into amplitude. Or what value of the wavelength, है ना? 2 pi into amplitude. This is important. Now, try to understand this, है ना? If this type comes, है ना? Generally, this is a repetitive question. They had asked it later on also, है ना? So just try to understand the funda. What they are saying: a tuning fork of frequency 512 Hz. So there is a tuning fork of how much frequency? 1200 Hz. Sorry, 1512 Hz. 1512 Hz makes 4 beats per second with a vibrating string. So there is a vibrating string also whose frequency is unknown, but they are saying together they are making how much? 4 beats per second, है ना? 4 beats per second, है ना? So how do you find this? You do f2 minus f1 or f1 minus f2. So f2 either it will be 516 Hz or it will be 508 Hz. है ना? Fine. The beat frequency decreases to 2 beats per second when the tension in the piano string is slightly increased, है ना? So you know that when you increase the tension, है ना, the frequency in this string will increase, है ना? Okay. Now they are saying that this is 512 Hz only. Okay. You had increased the tension and all that, such that f net here becomes how much? 2 beats per second. F net becomes 2 beats per second, है ना? So if you increase the tension, this frequency must increase. So let us figure out what would be the correct answer, है ना? Now, अरे भाई frequency is directly proportional to tension, ना, है ना? So this frequency must increase. So this has an option to become 517, है ना? 518, है ना? But if you take the difference is increasing, it is not decreasing. So this can't be your answer. Try to increase this. This has an option to become 509 Hz, and this has an option to become 510 Hz. Now see 512, 510. Subtract them, you get 2 hertz. So this was your initial frequency of the piano before increasing the tension, that is 508 hertz. A good one. Fine, clear? Any doubt, any query? Please let me know. Property wala to you can easily do. ये भी आप कर ही लेंगे. अच्छा, दिस इज इम्पोर्टेंट. हाँ ठीक है, ये कर लेते. अरे देखो ना, which of the following statement is false regarding electromagnetic waves property? This is correct, this is true. These waves do not require material medium to calculate. This is also true. Both electric and magnetic field vectors attain maximum minima at the same place and time. The energy of the electromagnetic wave is divided between the electric and magnetic vector. Yes, this is correct. Both the electric and magnetic field vectors are parallel to each other and perpendicular to the propagation. No, this is false. They are perpendicular to each other also. Fine. चलिए आगे बढ़ते. This is important. Try this out. Pause the video and try the question yourself. Pause the video and try the question. A ray of light traveling in a transparent medium of refractive index mu falls on a surface separating the medium from air. ठीक है. At an angle of 45 degree. ठीक है. A ray of light traveling in a transparent medium of refractive index mu, okay, here the refractive index is mu, falls on a surface separating the medium from air at an angle of incidence 45 degree. I is equal to 45 degree. For which of the following values of mu the ray can undergo total internal reflection? For which of the following the ray can undergo total internal reflection? Now you know that to undergo total internal reflection, my angle should be greater than the critical angle. I should be greater than the critical angle. You can just write sin I must be greater than sin IC. Sin I must be greater than sin IC. यहाँ पे it is here. यहाँ पे it is here, है ना. What is sin IC? Sin IC can be written as refractive index of this medium, denser medium, divided by refractive index of एयर में जा रहा है ना, 1 by mu, ऐसे लिख सकते हैं, sin 45 डिग्री. आया ना. तो mu must be greater than 1 by sin 45 डिग्री. एक मिनट. और which of the following value of mu the ray can undergo total reflection करवाना है ना हमें. हाँ ठीक है, सही तो जा रहे हैं. sin 45 डिग्री is 1 by √2, तो ऊपर आ जाएगा √2, है ना. तो mu must be greater than √2, that is mu must be greater than √2 का वैल्यू is 1.414, है ना. Which of the following is 1.414 greater than 1.414? Only option number 4. Clear? Any doubt, any query, please let me know. Root 2 is 1.414, root 3 is 1.732. Okay, good one. Yes, I hope you guys are there. Let me know in the chat section, guys. Hit the like button. Mains के question we are gonna discuss, है ना? अच्छा, after 30 questions, I will pick mains question, है ना? 30 questions के बाद mains के सवाल उठा लेंगे. Two positive ions each carrying a charge q, है ना? So there are two positive ions each carrying a charge q. Okay. And separated by a distance d, if F is the force of repulsion between them, the number of electrons missing from each ion will be. See, force is equal to K Q1 into Q2 by D का square, है ना? D is the distance between them. अच्छा, how is this charge Q created? N electrons would have left, charge on each electron E. ये थोड़ा सा, this was too easy, but still during the time of exam it didn't hit it a lot many students. FD square by K, है ना? E square भी आ जाएगा. K E square, है ना? Where n is the number of electron. Take root both sides, है ना? तो K is nothing but 1/4 pi epsilon naught. यही बन रहा है. N is the number of electrons missing. question. अरे भाई, see, most of the students do this wrong, है ना? But still, this has been asked twice in last 4 years, है ना? 5 years, 5 to 10. 2005 to 10. A square surface of length L meter in the plane of the paper is placed in a uniform electric field acting along the same plane at angle theta with the horizontal side of the square as shown in the figure. The electric flux linked to the surface, okay, electric flux पूछ रहा है. Electric field into A into cos theta. See, electric field is like this. दिखाता हूँ. Suppose here is the tap. Electric fields are like this, parallel to this plane, है ना? Area vector would be like this, है ना? So electric field is like this and area vector is like this. So angle between them is 90 degree, है ना? What is cos 90 degree? Cos 90 degree is 0. So flux linked with this surface is 0 because lines are not crossing through it, है ना? They are just passing parallel, touch करके निकल रही है. ये भी अच्छा है. ठीक है, अभी देखिए. So tricky but very easy. If N1 capacitor, a series combination of N1 capacitor. ठीक है. How many capacitors are there? N1. ठीक है. So what will be the C equivalent? Each is having a value C1, है ना? तो C1 by N1. ठीक है. Charged by a source of potential difference 4V, है ना? They are charged by a source of potential difference 4V. Okay. When another parallel combination of N2 capacitors. How many capacitors are there now? You can just think like this. N2 capacitors are there, and what will be the C equivalent? N2 into equivalent capacitance, into capacitance of each of them. Fine. So you must know the formula ki if all of them are having the same capacitance, so it is NC in parallel, and in series it is C by N, है ना? Okay. इसको टाइमर की जगह एक काम करते हैं, we can just use stopwatch. Okay, ठीक है. Now when another parallel has the same total energy in it as the first combination when the value of C2 in terms of C1. So they are saying that whatever is the energy stored in this, is equal to energy stored here. Fine. So what is the value of C2 in terms of C1? What is the energy stored here? Half CV square equivalent into how much potential is there? 4V. Half CV square. Okay. So half C equivalent is how much? C1 by N1, 16V square. What is the energy stored here? Half N2 into C2. It is charged by a source of V, है ना? V से charge करा था. Half into C equivalent into V square. So they are saying U1 is equal to U2. Okay. Half C1 by N1 into 16V square. Half N2 into C2 into C2 into V square. Half and half gets cancelled out. V square and V square gets cancelled out. Right. So you have to write C1, the value, value of C2, है ना? C2 लिखना था. C1 16 times C1 by N1 into N2. आ गया C2 आपके पास. ठीक है. 16 times C1 into N1 into N2. Again, this is a good question. अच्छा सवाल था. I liked it. Fine. Clear? Let me know in the chat section how much percentage is it clear to you, है ना? अच्छा, type how much percentage is it clear to? Clear with percentage. For example, you are understanding 40% to write 40%. You are understanding 80% to write in the chat section clear with 80%. Potentiometer से सवाल था. This is again. वैसे तो less chances are there. They are gonna ask you. ठीक है. देखो, the concept is very simple. The potential difference is equal to I into R equivalent, and that is equal to K into wherever the null point is reached. So they are saying that a potentiometer of circuit is set up as shown. The potential gradient across the potentiometer wire is K. ठीक है, ले लिया K. And the ammeter present in the circuit reads 1 ampere. How much current is there? Throughout 1 ampere है, तो if you want you can write 1 ampere here. चलो लिख लेते हैं. K times L. Okay, when 2 key is switched off, the balance point when the key between the terminal 1 and 2, 1 and 3 is plugged in are found to be at length L1 and length L2. ठीक है. When 1 and 2 are connected, now when 1 and 2 are connected, only resistor R is there in the circuit. When 1 and 3 are connected, the resistor R and X both are there in the circuit. ठीक है. Are found to be length L1 and L2 respectively. The magnitudes of the resistor R and X in ohms are. Let us connect 1 and 2 first. R equivalent will be R, and you got a null point at L1, है ना? R is equal to KL1. First equation. Now, so this can't be the answer. This can't be the answer. X की value पूछ रहे. Connect these two. R equivalent will be R plus X. KL2. X is equal to KL2 minus R. KL2 minus KL1. L2 minus L1. Option number 3. Fine. Clear? Again, a good question. By chance, if they ask, you should know. By chance. पूछ लिया तो. This is important because galvanometer में once in 2 years they generally ask, they do ask the question, है ना? And I think this year also they had asked. A galvanometer has a coil of resistance 100 ohm. ठीक है. And gives a full scale deflection for 30 milliampere. So how much current can pass through this? 30 milliampere. ठीक है. If it is worked as a voltmeter of 30 volt है ना range, the resistance required to be added. Now to convert a galvanometer to voltmeter है ना, you will have to convert you will have to connect a resistance in series. Let us suppose you had connected R. Now they are saying that it can measure how much? 30 volt. Okay. This is nothing but V1 plus V2. V1 is how much? Potential across this. V2 is how much? Potential across this. Potential across this. Fine. V1 plus V2. V1 is how much? This current into resistance of the galvanometer. V2 is how much? This current into resistance of this galvanometer. I you can take common. 30 milliampere means 30 into 10 raised to the power minus 3. G is how much? 100 plus R is equal to 30. This gets cancelled out. 100 plus R is equal to 1. And this 10 raised to the power minus 3 goes here. 100 plus R is equal to 10 raised to the power 3, or you can say 1000. So R will be how much? 1000 minus 100, 900. Option number 2. Clear? Any doubt, any query, you guys can ask. है ना, galvanometer they do ask the question, but they had already asked in the third May wala attempt, जहाँ तक I remember. So less chances are there. Kirchhoff's law, junction law follows charge, this follows energy, both are correct. इस पे तो वैसे m is equal to ZIT होता है फॉर्मूला, है ना. This is Z. This can be written as power by voltage they had given, है ना. तो यहाँ पे वैल्यू सब्सटीट्यूट कर लेना. For a minute means 60 seconds. इसमें भी कुछ नहीं है. Now, whenever this loop is placed in magnetic field, you know that net force experienced by it must be 0. So they are saying one of the arms, it is experiencing a force of how much F. Okay. So this must experience force F. This must experience force F. So this will also experience force F. Since it's opposite to this, so you can just write minus F. Option number 3. This will balance cancel out each other. So they were asking the net force by the remaining arms, है ना? Remaining arms. Remaining arms. Remaining arms. Good one. Try this out. पूछ सकता है. Oh. अच्छा, people are not responding in the chat section. हाँ जी भाई. Why? Yes, why people are not responding in the chat section? Try this out. Okay. Someone is saying ki how long the session will be, है ना? So I would just like to say 2 lines on this, है ना? In Hindi I would be saying, इरादा कर लिया है ऊंची उड़ान का, इरादा कर लिया है ऊंची उड़ान का, तो फिजूल है पूछना कद आसमान का, right? So if you have decided to clear this exam, है ना? So there is no point in asking, right, how much time it will take. Okay, fine. चलिए, a thin ring of radius r meter has a q. A thin ring of radius r meter has charge q coulomb uniformly spread. The ring rotates about its axis with a constant frequency f, है ना? So this is constantly rotating about this axis, frequency f. So basically this charge q is rotating. So it acts as a current. Current is how much? Q by T, or you can write Q into frequency f. Okay. Okay. The value of magnetic induction at the center. What is the magnetic field at the center due to a current carrying loop or current carrying circular wire? Mu naught into I by 2R. Mu naught Q into F by 2R. Q into F by 2R. Fine. Clear? Any doubt, any query? Tram batch. ये शायरी नहीं भूलेगी. अच्छा, okay, Numan, you are there. But I didn't say this shairi ever in tram batch. Huh? I didn't say it. Okay, so that they have very less retention, है ना? And energy loss is less, है ना? That area under the graph is very less. Try this out. अच्छा, I did, मुझे याद नहीं है. Numan, please share this link with your friends, है ना? Those who are preparing for NEET. Okay, so you know that time period के बारे में ही बात हो रही है क्या? हाँ. Time period is equal to 2 pi under root I by mb, है ना? Time period is inversely proportional to the magnetic field, है ना? T1 by T2, B1 by B2. They are saying it is 2 seconds when the magnetic field is 24 micro Tesla, है ना? 2 seconds. The magnetic field is 24 micro Tesla. Okay. And a horizontal field of 18 micro Tesla is produced opposite to the Earth's field. Okay. So 24 is acting in this direction and 18 is acting in the opposite direction. So net will become 6. And so do not write 18 as B2. No. Okay. 18 is acting in the opposite direction. 24 was already acting. So net will be 6. So they are asking what will be the time period 1, 2, 3, 4. T2 you will be getting it as 2 goes here. Under root 4 is 2. Now 4 second is T2. Option number 1. Okay. Similar question they had asked multiple times. Okay. Please. Achha, okay. I think I need to get side. Read the question. Read the question. Pause the video and read the question. Achha, I will just switch to mains question immediately after this. Okay. Okay. One more question we would be doing, that is important. A circular loop is placed in uniform magnetic field of 0.005 Tesla. 25 Tesla. Fine. With its plane perpendicular to the loop, the radius of the loop is made to shrink. So radius is shrinking at a rate of 1 mm per second. Or 10 raised to the power minus 3 meter per second. Okay. The induced EMF when radius is 2 centimeter at R is equal to 2 centimeter. Divide by 100 or 10 raised to the power minus 2 meter. The plane perpendicular, the radius of the loop is the induced EMF. Acha, EMF they are asking. Hai? EMF is minus d phi by dt. Just magnitude ke bare mein I'm just talking about d phi by dt. This is B into A, dA by dt. We had done this question earlier also. Area is how much? Pi r square. Uh, 2r dr by dt. Magnetic field is 0.05. Magnetic field is 0.025. Pi value is pi only. Yes. Twice of at radius of 2 into 10 raised to the power minus 2 into dr by dt. That is 10 raised to the power minus 3. $25 into 250, 50 into 200. 10 raised to the power 3, 3, 6, 7, 8. Pi by 10 raised to the power 6 volt. If you have to change it into microvolt, you can change it because options are like that only. 5 microvolt. Fine. You will have to multiply this by 10 raised to the power 6. So you will get it in microvolt. See the options. All of them are in microvolt. Fine. Achha, this is an important one. Try this out. Pause the video and try this out. Pause the video and try this out. Yes. Yes, guys, can you hear me? Hello, 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 hello. Okay. In the given circuit, the reading of voltmeter V1 and V2 are 300 volts each. So this is connected across inductor. This is connected across capacitor. And so V1 and V2 are same. The reading of the voltmeter V3. Now, if they are same, then it is at resonance. It is at resonance. So this can behave. You can think like this as a pure resistive circuit. So they are asking how much is the current V by R. It is 220 volt here and 100 ohm here. 2.2 ampere. Fine. What else here? Okay. Achha, ammeter key reading you had told. Okay. What about the V3 key reading? V3 will be how much? Current across this into resistance. 2.2 into 100, 220 volt. मतलब ये पूरा का पूरा would be there. Okay, so here you just should know the property of that, है ना, ammeter. चलिए मेंस के क्वेश्चन देखते हैं एक दो. मेंस, है ना, ऑल इंडिया प्री मेडिकल टेस्ट मेंस. अच्छा, wherever they had written NEET, so it is not NEET. By default, understand this to be AIPMT. Okay, fine. ठीक है. So now the question level is gonna be good. ठीक है. तो वो previous 20 questions भी we will be discussing. Don't worry, I will come back to them. Session will be of 1.5 hour more. चलिए. X, Y, Z. A current loop consists of two identical circular semicircular parts, each of radius r, one lying in the xy plane and other in the xz plane. One lying in the xy plane and another lying in the and another in the xz plane. Fine. Semicircular loop. Okay. If the current in the loop is I, okay, let us send some current. Current in the loop is I. Okay, fine. The resultant magnetic field due to the two semicircular parts at their common center. So they are asking what is the resultant magnetic field at the common center. First of all, let us forget this loop is there. So magnetic field due to this semicircular part is given by mu naught I by 4r. Due to the entire circle, it would have been 2r, but I had just divided it by 2 because it's semicircular. Due to this much. Okay, now just take the field. Take the field. Where would the magnetic field look? Due to this upper part. Due to this upper part. तो ये inwards कही जाती है आपको दिखेगी. Where will this magnetic field due to this portion will look? ये कहीं नीचे जाती हुई दिखेगी. Let us suppose this is B1, this is B2. दोनों एक दूसरे के परपेंडिकुलर होगी. Yes or no? Yes or no? है ना. अरे भाई देखिए ना. Suppose this is there. है ना. One is in this XZ plane, another is in this XY plane. है ना. तो मैग्नेटिक फील्ड ड्यू टू दिस विल बी इनवर्ड्स. है ना. इसकी वजह से ऐसे करंट जा रहा है इनवर्ड्स. है ना. इसकी वजह से डाउनवर्ड्स. ठीक है. Watermelon was there inside that. हाँ जी. So net magnetic field will be what? They are perpendicular to each other. Under root B1 square plus B2 square. Now the thing is that both of them have the same current passing through across them, right? I value is same, right? So magnetic field because of both of them will be same. Root 2 times magnetic field. Root 2 times magnetic field is how much? Mu naught by 4r. You can just rationalize them. This will become 2. This will cancel out on 2. Mu naught I by 2 root 2 r. Clear. Okay, this is based on logic gates. Very simple. They are saying they had given input, both the inputs, and they had given you output. Okay. So which of the following gate it is representing? है ना. So whenever this comes, है ना, A and B are the input. Just make the logic table, है ना, truth table, and Y is the output. है ना. So when it is 1, this is 1. So this is how much? 0. Okay. When this is 0, this is 0. It is 1. Okay. When this is 0, this is 1. This is 1. When this is 1, this is 0. This is still 1. Okay. So which gate is it? Which gate it is? I think it is. Acha, if this would have reverse, है ना, 1 0 0 0, then definitely it would have been AND gate. Okay. But this is something reverse of AND logic, है ना. So this must be a NAND gate. NAND gate. NAND gate. Okay. They are saying that two parallel metal plates having charge plus Q and minus Q face each other at a certain distance between them. Now plus Q and minus Q. Okay. Now if the plates are now dipped in kerosene, both the plates are now dipped in kerosene. Plus Q and minus Q. Okay. Now kerosene is there in between. Now, the electric field between them will what happen to the electric field? So let us try to analyze it. When air is between them, electric field between them is given by sigma by epsilon naught. Okay. Now kerosene is dipped, electric field E dash is given by sigma by epsilon of the medium, है ना? E dash. Epsilon of the medium is given by capital K into epsilon naught. Okay. This is how much? This is the original electric field, है ना? E by K. E dash. So this is the original electric field, है ना? You are dividing it by a number greater than 1, है ना? तो E dash you will be getting lesser than E. Okay. So it reduces, it decreases when you dip it in the kerosene. Okay, again a good one. Mains question है, mains. ये तो आसान है. See this one, again a good one. Okay, try this out. Pause the video and try the question yourself. Pause the video and try the question. देखिए, now here they are saying that a student measured distance traveled in free fall initially at rest by given time. So distance in free fall, it is given by s is equal to ut plus half at square, है ना? ut plus half at square. Free fall है तो acceleration is g half gt square. ठीक है. Initial speed is 0, तो s is equal to how much? s को ले लेते हैं हम, h भी ले सकते हैं वैसे, बट ठीक है. h is equal to half gt square. Okay. G will be how much? 2h upon t square is equal to g from here. Now they are saying if the maximum percentage errors in the measurement of this distance, that is h, and time are E1 and E2 respectively, then the percentage error in the estimation of g, then the percentage error in the measurement in the percentage error in the measurement of the distance, it's given by d1, oh sorry, this is E1, and that in the measurement of time, it is given by E2. Oh, you have the formula. Can I apply the, they're asking percentage error in G, है ना? Delta G by G into 100. Can I apply the error wala formula? ना delta H by H into 100 plus it's square here, so I will be writing square. Now delta T by T into 100. Can I write this? Delta H by H is how much? E1 plus twice of E2. Is this in the option? Is this in the option? Option number 2, G. Anji, clear. Yes, Numan. And I think only 2 of us are so active in the session. I come and you just reply. Others they just join and they just leave. है ना? Trust me, you study throughout the day, and then at the end of this day, at the end of the day, come to the session. It would be the best recapitulation. है ना? In this session, you just have to take the feel. Ki are you, if it comes in exam, will you be able to solve or not? Of course, I can't give you the time that take 2 minutes and solve. But yes, you can just take the feel, vibes. ये तो कर ही लोगे भाई. Electric field at a distance 3 by r by 2 is of the shell is outside the shell, it's given by this. Electric field at a distance r by 2, that is inside, they are asking. It is 0. इसमें सोचना ही नहीं. Nothing to think. Important. Now, whenever photons fall, okay, they eject the electrons. They eject the electrons. Fine. So you think like this: one photon ejects one electron. One photon will eject one electron. More the number of photons, more would be the ejection. That means more would be the current, photocurrent, है ना? Now they are saying when phonochromatic radiation of intensity I, this intensity is proportional to number of photons. And their maximum kinetic energy, okay, the number of photoelectron and the maximum kinetic energy is given by K and T respectively. If the intensity of radiation is 2I, that is you had doubled the number of emitted photoelectrons and their maximum kinetic energies. So you had doubled the intensity. That means you had doubled the number of photons, which was proportional to number of electrons ejected. Not the kinetic energy of the electron. Not the kinetic energy of the electron. You increase the intensity, number of photons increases, and number of electrons ejected will be increasing, है ना? Because each photon is, you can think like that, ejecting one electron, है ना? More photons, more electrons, है ना? ठीक है. So n was the number of photons ejected, है ना? You have doubled the intensity, so this will become 2n. But you hadn't changed the energy of the photon, so kinetic energy of this electron will also not change. So kinetic energy remains T only, 2n and T. 2n and T. Anji, yes. Okay, the strength has yes. भाई तान्या, पढ़ाई कर लो, है ना? मस्ती करने की जगह बच्चे मेरे चैट में आके मस्तियां कर रहे हैं. ओके. The electric field of a electromagnetic wave in free space is given by this. ठीक है. They are saying which of the following pairs are correct, है ना? तो अब यहाँ पे you have to check the pairs which are correct here. ठीक है. Let us see. The wavelength is this much. Okay. चलिए देखते हैं. ठीक है, निकालना पड़ेगा. The wave is propagating along positive x direction. This is wrong. Now this is not propagating along positive x direction. आप देख सकते हैं both the signs are same. ठीक है. The wave amplitude is 10 volt per meter. Yes, you can say this because this is the amplitude. Okay. The wave number k. अच्छा, so the option which has C in it would be correct. So these two options are by default eliminated. The wave number k is 0.33 radian per meter. Okay. And the wavelength is this much. अब देखिए, ओमेगा is equal to 10 raised to the power 7. Omega from here, if you compare it, you will get it as 10 raised to the power 7. Just a second. देखिए, can I write C is equal, अच्छा, omega is nothing but 2 pi into f, which is 10 raised to the power 7. Frequency from here 10 raised to the power 7 upon 2 pi. Make sure you hit the like button and share the stream link with your friends. Okay. हाँ जी, क्या कह रहा था मैं? Okay. So C is equal to lambda into frequency. Lambda will be how much? C by f. C is how much? 3 into 10 raised to the power 8. Frequency is how much? 10 raised to the power 7 upon 2 pi. 2 into pi. है ना? ये गया यहाँ से 3 to 6. 6 pi into 10 raised to the power 1 ही आ रहा है, हाँ, या फिर 60 pi. 60 into 3.14 you do, roughly you get it as 188.4. A and C. A and C. This was important. Try this out. Pause the video and try this out. Take the feel. Will you be able to do it or not? Okay. Okay. Yes, Numan, I hope you would have realized how serious the NEET aspirants, Indian aspirants, a few of them are there. है ना? कह रहे कंपटीशन वाला ज्वाइन कर रहे थे, लेकिन वहां चैट ज्यादा हो गई थी तो हम इधर आ गए. द कंपटीशन वाला क्लास आई थिंक इट्स गोइंग देयर ओनली, एकदम साथ वाली क्लास में ही चल रही है. यस, मैम इज टेकिंग द क्लास. ओके फाइन. See, they are saying that the speed of the light in medium m1 in medium m1 is this much and medium m2 it is this much, है ना. So can I calculate refractive index? Can I calculate refractive index of this medium? Yes, है ना. अच्छा हाँ, स्पीड दे रखे है ना, है ना. एंड इसमें भी स्पीड दे रखे, v1 v2 लिखता हूँ, एक मिनट सॉरी. 1.5 into 10 raised to the power 8 meter per second, ठीक है. And v2 is given to you as how much? 2 into 10 raised to the power 8 meter per second, ठीक है. सही है. Any doubt, any query? ठीक है. Can I calculate refractive index of first? Yes, 3c by v1, है ना. तो I would be getting it at 3 by 1.2 ना. N2 कितना आएगा? c by v2 ना. c is how much? 3 into 10 raised to the power 8, है ना. तो ये आ जाएगा 1.5. Okay. A ray of light enters from medium 1 to medium 2 at an incidence from m1 to m2, ठीक है, at an incidence angle I. If the ray suffers total internal reflection, the value of I is. Now, for total internal reflection to happen, it must enter from a denser medium to rarer medium. Is it happening? Yes. Is it happening? Yes. No. They are saying that it was incident at an incidence angle I. At an incidence angle I. Okay. Now, here sin I definitely must be greater than sin IC for TIR to happen. Sin I must be greater than sin IC for TIR to happen. Now, what is sin IC? Oh, refractive index. Suppose this is medium n1, this is medium n2. Okay. Refractive index of the first medium, second medium, divided by the refractive index of the first medium. है ना. So sin I is greater than n2 is how much? 1.5. This is how much? 2. This is 3 by 4. I must be greater than sin inverse of 3 by 4. Equal to or greater than sin inverse 3 by 4, है ना. Equal to वाला भी लेके चल सकते हैं आप जब just grazes the surface वाला केस होता है. Fine. ठीक है. तो you must know this condition for this entire thing to happen. And rarer by n denser. So easy question. They are saying that a ray of light is incident at 60 degree. These are the mains question, है ना. Angle of prism is 60 degree. ठीक है. At the minimum deviation position, at minimum deviation, if you are not aware, let me just tell you, R1 is equal to R2. And instead of capital A, you can just write R1 plus R2. This is 60 degree. So 2R is equal to 60 degree. R is equal to 30 degree. Okay. The angle of refraction at the first phase will be. ठीक है भाई, यही R1 ले लो. Angle of refraction they were asking 30 degree. ये तो नहीं पूछेगा. This is a good one. ठीक है. Okay, I can't tell how much I'm enjoying taking this session, you know. पूरा ऐसा, it will take 1 hour more. Okay. सही सही है सही है सही है. Read the question, read the question. Oof. You know, it's very hot here in India, and we recently got a new maid for our household errands, है ना, cleaning and all that. You know, the first day she came and she said, AC चला दो नहीं तो मैं काम नहीं करूँगी. Without AC, I won't be working. I didn't had AC even at my home, right? For her in my that room, right? For her, we have to arrange a AC. So much tantrums the maids are having here. The additional kinetic energy to be provided to a satellite of mass small m revolving around a planet of mass capital M. Okay. So there is a satellite which is revolving around this of mass small m, and mass of the planet is capital M. Okay. To transfer it from a circular orbit of radius r1, ठीक है, to a radius of r2, to a radius of r2. Fine. R2 is greater than R1, so they are asking how much energy is required, है ना. So at this first position, there would be some total energy minus G capital M into small m by R1, twice of R1. If you have to take there, it will possess how much energy minus G capital M into small m by twice of R2. Correct? That much would be, it is moving, है ना, it is possessing some kinetic energy as well as some gravitational potential energy. So they are asking to take it from here to here, from this energy to this energy, how much additional kinetic energy I will have to give. So I will have to give some kinetic energy to T1 so that it reaches T2. And so K will be how much? T2 minus T1 minus G capital M into small m by twice of R2. Minus minus this will become plus Gm into small m by twice of R1. G capital M into small m by 2 minus 1 by R2 plus 1 by R1. Is this in the option? 1 by so simple question, basic concept पे बना हुआ है ना. So you know that whenever a projectile is thrown, the horizontal velocity, ठीक है, it does not change in absence of air friction, which is the general case we take, है ना. So whenever this projectile is thrown, whatever is the horizontal velocity here, remains same. ठीक है. So let us suppose the speed is v here, है ना. It must be u cos theta only, because here the horizontal speed is u cos theta, where theta is the angle of projection. Now they are saying speed of projectile at its maximum height is half of its initial speed. This is u by 2. U से u gets cancelled out. Cos theta is 1 by 2. It happens at cos 60 degree. So theta from here, you get it as 60 degree. Option number 1. Fine. Clear? Done, 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 done. Acha, there was one very good question. I am waiting for it. कहाँ गया? ये रहा. ये भी नहीं है. ये वाला भी नहीं है. ठीक है. Try this out. Try this out. हाँ जी, हेलो 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 हेलो, यस आई होप यू गाइस गॉट द आंसर, है ना? ओह, चलिए चलिए चलिए, लेट अस डू इट, लेट अस डू इट. Just in the adjacent room, the competition wala class is going on. Yashika ma'am is taking that. ठीक है, okay. So what they are saying that, क्या कह रहा है देखते हैं. So there was a circular disc of radius r and mass 9m and mass 9m. Fine. A small disc of mass m and r by 3 radius. A small disc of mass m and radius r by 3. Mass m and radius r by 3. Mass m and radius r by 3 is removed concentrically. अच्छा, कंसेंट्रिकली हटाया क्या? एक सेकेंड, कंसेंट्रिकली हटा. कंसेंट्रिकली निकाला. The moment of inertia of the remaining disk about an axis perpendicular to the plane of the disk and passing through the center, है ना? So about this axis you have to find the moment of inertia. ठीक है, fine. So whatever is the moment of inertia of the original disk minus moment of inertia of this black disk, and you will get the answer. Fine. हाँ जी, yes or no? ठीक है. I net will be what? I1 minus I2, है ना? I1 is the moment of inertia of this entire disk, है ना? ये पूरा. What it would have been? 1 by 2 mass. Mass is how much? 9m into radius का square. ठीक है. I hope you remember moment of inertia of a disk is given by 1 by 2 mr square. ठीक है. Moment of inertia for this disk will be given by I2 into 1 by 2 mass is m and r square by r by 3 का square, r square by 9, 3 square is 9. 9 by 2 mr square minus I2, 9 to 18, 1 by 18 mr square. एक मिनट रुकिए. 1 by 2 mr square mr square mr square mr square. अच्छा अच्छा, ओके फाइन फाइन, ये नहीं लेना था, आई एम सॉरी, mr square लेना था. फाइन, स्मॉल मिस्टेक, ये mr square था. ठीक है, नॉट, हाँ डिस्क के लिए, वो रिंग के लिए हार्ड रिटर्न mr square है ना, रिंग के लिए गलती से लिख दिया था. फाइन, ठीक है. सॉल्व दिस सॉल्व दिस सॉल्व दिस सॉल्व दिस, है ना? हाउ मच यू वुड बी गेटिंग? 9 mr square माइनस 1 by 9 mr square. ठीक है, 9 9 81 81 माइनस दिस 80 बाय 9. एक मिनट यार, कहाँ गलती हो रही है? 2 तो वैसे सही लिखा था मैंने. 2 18, अरे सही तो लिखा था, 2 ही तो था. हाँ, 2 इंटू 2, सही लिखा है भाई. सही लिखा है, इंटू 9 81 mr स्क्वायर माइनस 1 mr स्क्वायर. सॉरी, हाँ डिस्क के लिए तो इट इज 1 by 2 mr स्क्वायर ओनली ना, हाफ इंटू मास इंटू स्क्वायर ऑफ द रेडियस. ठीक है, सही तो लिखा था. 9 to 18 80 mr स्क्वायर बाय 18, है ना? तो ये कट गया, कितना आ जाएगा? 40 by 9 mr स्क्वायर, है ना? 40 by 9 mr स्क्वायर, 40 by 9 mr square. Is this in the option? Yes, option number 8. Fine. क्लियर एनी डाउट एनी क्वेरी? ठीक है, एक बढ़िया सा सवाल, आई एम गोना ब्रिंग इट फॉर यू। एक बारी पहले ये कर लेते हैं ना, द पार्टिकल फॉलोज विच ऑफ द पाथ, है ना, विच ऑफ द पाथ इट इज फॉलोइंग अ पार्टिकल इन एक्स वाई प्लेन इज अकॉर्डिंग टू दिस इक्वेशन, है ना, ठीक है। Yes, done. Okay, fine. Yes, option number 2 बिल्कुल सही है ना, because they are saying that let us square both sides, x square a square sin square omega t, ठीक है, y square is equal to a square cos square omega t, ठीक है, add both of them, x square plus y square, a square you can take common, sin square omega t plus cos square omega t, ठीक है, x square plus y square is equal to a square, right? So this is equation for circular path. This is equation for circular path, option number 2. Next up we have this. The torque on the solenoid having these many rings, this much cross sectional area, this much current passing through it, and in this much magnetic field at an angle of 30 degree. Torque is equal to mb sin theta, है ना, sin 30 degree I would be writing. M is how much? I into A, है ना, number of turns, in fact I should write I into A. B sin 30 degree is how much? 1 by 2. Number of turns 2000. I to area, कहाँ है area, लिखा है क्या? Area is 1.5 into 10 raised to the power minus 4. B is 5 into 10 raised to the power minus 2 into 1 by 2. सॉल्व कर लीजिएगा इसको. This is again a good one. You have to tell which of the following statements are possible. Hello, can you hear me? Which of the following statements are possible? So there can be more than one correct answer. Yes, got it. ठीक है. They are saying a particle having mass this much carries charge this much. The particle is given an initial horizontal velocity this much, है ना. देखिए, there is a charged particle. Okay, there is a charged particle having some charge q. ठीक है. In the presence of electric field and magnetic field, to keep the particle moving in horizontal direction, okay, you had given it some initial velocity v. ठीक है. Now both electric field and magnetic field are there into the picture. Both electric field and magnetic field are there into the picture. Now they should be acting such that this particle goes undeviated. Okay. Now one possibility is that the magnetic field, the magnetic force and electric force, because of these respective fields, they cancel out each other. They cancel out each other, है ना. So for that, both of them must be acting perpendicular to the velocity of the particle and perpendicular to each other, है ना. यही electric field की direction हो जाएगी, and magnetic field should be perpendicular to this and of course perpendicular to this, है ना. So both B and E are mutually perpendicular and perpendicular to the direction of velocity. So C is absolutely correct. Now, is there any other way in which I can make this particle move horizontally only? Only yes. See, if magnetic field is also acting in this direction, so it cannot deviate the particle. है ना? It must be acting perpendicular or at some angle, okay, to deviate it. And electric field is also in this direction. Fine. So both B and E should be along the direction of velocity. So through this also you can achieve your target. So B and C, option number 3. Fine. In both the ways, it can go undeviated. No mathematical calculations, anything. Read the question, read the question. Those who are watching recorded session, pause the video and try the questions. Pause the video and try the questions. Anji, yes, Numan. Okay. Make sure you hit the subscribe button, guys. है ना? I think after I had started taking the session, roughly 1300, not 1300, 130 followers, subscribers have increased. Of PW Gulf YouTube channel. See how much popular I am becoming. 130 subscribers had increased. Okay, the binding energy per nucleon in a deuterium and a helium nuclei, है ना? I hope you know deuterium. 1 proton, 1 neutron. Oh, sorry, तो यहाँ पे 2 आ जाएगा. And helium 2, 4. Fine. Now they are saying that respectively which binding energy per nucleon इसकी कितनी है? 1.1 mega electron volt per nucleon. Here it is 7 mega electron volt per nucleon. Okay. When two deuteriums fuse together, so two deuteriums are fusing together to form a helium nuclei. Okay. The energy released in this fusion will be, है ना? So they are asking how much energy will be released. Okay. So let us figure it out. How much is the energy associated with these 4? This is per nucleon, है ना? And how many nucleons are there? 2 in one atom and 2 another deuterium atom, है ना? So 2 plus 2, 4 into 1.1. So 4.4 mega electron volt here. How much is there? 4 nucleons are there, 7 mega electron volt per nucleon. So 4 into 7, 28 mega electron volt. How much is the energy released? 28 into 4.4 minus 4.4. I'm sorry. So how much it will become 24? 23.6 mega electron volt. Option number 1. Clear? Any doubt, any query? You guys can let me know in the chat section. Fine. Next. Achha, this is a good one where most of the kids found it difficult. Anji, yes. Fine. The electron in the hydrogen atom jumps from excited n is equal to 3 to n is equal to 1. N is equal to 2, n is equal to 3. Fine. Okay. Okay. So if the electron is jumping from n is equal to 3 to n is equal to 1, what will happen? A photon would be emitted. A photon would be emitted. Am I correct, guys? A photon would be emitted. Okay. Achha, next session would be happening on Thursday. है ना? You have Thursday previous year discussion. Friday would be there, and I will try that. Saturday also we have it. Okay, because tomorrow we are not happening. 2011, 2012, 2013. Okay, fine. Then next week we would be having 14, 15, 16, 17 and 18. Okay. है ना, फिर in one class I will try that I take multiple sessions. Okay, एक single दिन में. ठीक है. चलिए. And photo. हाँ. If the work function of the material is how much? 5.1 electron volt. Fine. The stopping potential is estimated to be, okay, how much is the stopping potential? ये पूछ रहे. ठीक है. And energy भी दे दी. Okay. So you should know how much energy would be, what would be the energy of the photon when it goes from n is equal to 3 to n is equal to 1. So that delta E energy of this photon. ठीक है. Energy at third minus energy at 1 कर लेते हैं ना. Minus 13.6 by 3 का square is 9. Minus 13.6, 1 का square is 1. No. Minus 13.6 you can take common. Minus minus plus हो जाएगा. 1 minus ये इधर ही आएगा. हाँ. 1 by 9 minus 1. ठीक है. So when you solve this, you roughly get it as 12.1 electron. Now they're asking you the stopping potential, है ना. यहाँ पे क्या पूछ रहा है? If the work function of the material is this much, the stopping potential is estimated to be how much? ठीक है. देखिए, kinetic energy, you know, energy of the photon minus work function. ठीक है. This can be written as E into stopping potential upon E minus phi naught. EV naught, 12.1 minus how much is the work function? 5.1. Subtract them, how much you would be getting? 7 electron volt. E and E gets cancelled out. V naught you get it as 7 volt. Is this in the option? Yes, option number 4. Fine. Clear? Any doubt, any query? You guys can unmute and ask. ये small c है ना? Small c, small v है ना? Small c, small v, small c, small v है ना? Small c, small c. Now tell me. So you know that capital C you would have studied molar heat capacity, है ना? Small c you would have studied specific heat capacity, and you would have studied this relation Cp minus Cv is equal to capital R, है ना? Mayer's formula, है ना? Mayer's formula. At constant pressure, at constant volume, है ना? So this capital C is equal to capital M into small c. Small Cp minus capital M into Cv is equal to R. Cp minus Cv is equal to R by M. Option number 3. Clear? Any doubt, any query? You guys can unmute. Oh, you guys can just type in the chat section and let me know. This is important, but if it comes in your exam, try to attempt it towards the end, है ना? Either leave it, है ना? थोड़ा सा टफ रहेगा. आज शायद आपको आंसर याद आ जाए. You may be able to learn the. Yes, I know, Numan. It reached 1K, है ना? That video. This is a good one. Try. Anji, yes. Anyone got the answer by any chance? I will solve it. Don't worry. I will solve it. है ना. ठीक, देखिए, now whenever, first understand the concept. They're saying that a condenser of capacity this much is charged to a potential difference of this much. Okay, the plates of the condenser are then connected to an ideal inductor of inductance this much, है ना. So the current through the inductor when the potential difference across the condenser reduces to V2, है ना. So this is basically discharge across the inductor. Initially you had a capacitor having capacitance C, and potential difference across this is V1. Now this capacitor is connected to an inductor, fine, so that afterwards its capacity, its potential difference drops to V2, है ना. यहाँ पे C था, अब V2 हो गया, CV1 CV2. Okay, now they're asking the current through the inductor, I की वैल्यू पूछ रहे. Now to solve this question, है ना, you slightly need to know a few basic concepts of when this inductor is connected to a, when this capacitor is connected to a inductor, है ना, कि what happens. देखो, charge at any time t it is given by q is equal to q naught cos omega t, है ना. So all the things are linked with this. If you want to know the derivation and all the things, let me know. ठीक है, but charge at any instant t is given by q is equal to q naught cos omega t. Fine. This is the maximum. Okay. Now, इसी को I would be using. ठीक है. Now, I is nothing but dq by dt. I is nothing but dq by dt. That is, can I differentiate this with respect to t? Yes. Cos theta का differentiation is minus sin theta, and इसका differentiation it will come omega t का sin omega t. So I you get it as minus omega into q naught into sin omega t. Fine. Okay. Any doubt, any query, you guys can just unmute and ask. Acha. What I can write instead of q naught? What I can write instead of q naught? Now see all the options very carefully, है ना. See, in all the options you will find some or the other thing written, है ना, that they have most of them, like a couple of them, they are having this 1 by 2 in the, they are having this 1 by 2 in the power. So for sure you will have to change it, है ना. You, some hint you would be able to get कि this sin omega t needs to be converted somewhat to cos, है ना. ठीक है, and I will be finding the value of cos omega t as well. अभी कैसे देखिएगा. Sin square theta plus cos square theta is equal to 1. Sin theta is equal to 1 minus cos square theta, take roots both sides. 1 minus cos square omega t raised to the power 1 by 2. अच्छा, अभी क्या कर सकते हैं. अच्छा, ओके. Q is how much? C into V. C into V2. Q naught is how much? C into V1. Cos omega t. C and C gets cancelled out. Cos omega t, you get it as V2 by V1. Cos omega t, you get it as V2 by V1. Omega naught is how much? Again C into V1. 1 minus उसका स्क्वायर कर दो V2 का स्क्वायर by V1. is to the power 1 by 2. Acha, instead of omega, 1 by root LC you can write, है ना, because L is also there in the options, है ना. 1 by root LC, C is there, V1. अच्छा, you can write it as V1 whole का square, है ना, ऐसे लिख लीजिए. V1 minus V2 root of V1 का square, because root is there and another root is there, है ना, numerator denominator में ले लिया. This entire thing gets cancel out, है ना. C को भी अंदर लिया जा सकता है क्या? हाँ, ये देखिए, this root C and this can be written like this, root C upon root L root of V1 square minus V2 square. क्या मैं ये पूरे को ऐसे लिख लूं? C into V1 square minus V2 square upon L. ठीक है. I know this was lengthy. As I said, if it comes in exam, so you have to just leave it. क्या ये ऑप्शन में है? Is this in the option? E into V1 minus V2 whole का square. Yes, पूरे पे रूट. ये रहा. V1 square minus V2 square. Clear? Clear? Please let me know in the chat section if it is clear to you. Okay. Now, they are saying that dependence of acceleration due to gravity on distance small r from the center of the earth assumed to be sphere of radius capital R or uniform density. Now, see, when you see from the surface, acceleration due to gravity reduces as you move up, it reduces as you move down. But you are not here seeing from the surface, but instead you are seeing it from the center, है ना. So when you move till the surface, so G increases. Am I correct? If you are starting from the center, okay, and when you move beyond that, G will reduce. So look for the graph where it is increasing and then it is decreasing, है ना. Okay, जा रहे हो हम कोई ध्यान रखिए. ओके, ठीक है. चलिए, मैं ही अकेला रह जाता हूँ पूरे स्टूडियो में. I'm left alone here in this entire studio. This is direct formula based. ये भी हो ही जाएगा आपसे. ठीक है, इजी है. अच्छा, ओके. Now let us come back to the prelims questions, है ना. थोड़े से prelims questions रह गए थे, around 20 of them. Let us do them. Primary, secondary. ठीक है, okay. Now ट्रांसफॉर्मर पे तो यू मस्ट नो लाइक प्रैक्टिस क्वेश्चंस, है ना, बिकॉज देयर इज हाई चांसेस एवरी ईयर दे गिव अ सिंपल क्वेश्चन ऑन ट्रांसफॉर्मर, है ना, एंड अ वेरी बेसिक रिलेशन इज अप्लाइड. NP बाय NS इज इक्वल टू VP बाय VS इज इक्वल टू IS बाय IP. ठीक है. A 220 volt input is supplied to a transformer. Okay. 220 volt. Okay. The output circuit draws a current of 2 ampere at 440 volt. Okay. How much current is this drawing? 2 ampere. Fine. If the efficiency of the transformer is 80%, the current drawn by the primary winding, है ना, इसकी efficiency is 80%. Okay. Let me pick this data, है ना, this formula. VP is how much? 220. VS is how much? 440. I secondary is 2 ampere. IP I do not know. Okay. This gets cancelled out on 2. IP is equal to 4 ampere. Okay. Right. Now, they are saying that it is having an efficiency of 80%. So, the current drawn by the primary winding of the transformer, ये तो after the efficiency of 80% is coming, है ना? 80% of I is equal to IP, है ना? So, I is 80 by 100. IP is how much? 4, है ना? 20 it goes on 4, 20 it goes on 5. This and this gets cancelled out. I is coming 5 ampere. Is this in the option? Option number 1. Fine. Done. Last how much time it will be taking? Last 15 more minutes, है ना? 15 minutes. 15 minutes. Board has hung. A source S1 is producing this many photons per second of wavelength this much, and another source is producing these many photons per second of this much wavelength. Then the power is equal to, है ना? You can just think like this: power is proportional to number of photons into energy of each photon, है ना? Number of photons into hc by lambda, है ना? hc is a constant, so power is directly proportional to n by lambda. Okay. Fine. So you can just solve this. P1 by P2 is equal to N1 by lambda 1 into N2 by lambda 2. Power of S1, अच्छा S2 is to S1. Just reciprocate it because they had asked P2 is to P1, है ना? Not P1 by P2. N1 is how much? 10 raised to the power 5. Lambda 2 is 5100 Armstrong. No need to convert because lambda 1 is also given in Armstrong. 5000 Armstrong. N2 is how much? 1.02 into 10 raised to the power 15. This gets cancelled out here, है ना? Two zeros gets cancelled out. 100 comes up here. Gets cancelled out on 2. This again gets cancelled out. 1 is to 1. 1 ही आ रहा है. Even if you reciprocate it, 1 by 1 is 1 only, है ना? Option number 2. That kinetic energy possessed by the charge is Q into V, है ना? यहाँ पे आप ये लगा सकते हैं, हो जाएगा. एक बार ही डायरेक्ट कर लेते. डायरेक्ट क्वेश्चन. डायरेक्ट क्वेश्चन. The potential difference that must be applied to stop the fastest photo electron emitted by nickel surface having work function this much and ultraviolet light of this much nanometer falls. Let us see how much energy this ultraviolet light has. Energy is hc by lambda of 1240 by wavelength is how much? 200. So roughly you get it as exact निकालना है क्या? नहीं. 62 6.2 electron volt. EV naught is equal to energy minus phi naught. 6.2 minus phi naught is how much? 5.01. Roughly 1.2 ही तो आ रहा है. ठीक है. ये भी you can do. अच्छा, try this out. Though it is again easy and too direct one, but still try it. Fine, got it, got it. Fine. अच्छा वहां पे it is -1.2 इलेक्ट्रॉन वोल्ट because it is required to stop the electrons, है ना, तो माइनस जरूर लगा लेना. चलिए लास्ट 2 3 4 क्वेश्चंस मोर है ना, 5 मोर क्वेश्चंस है ना. द मास ऑफ लिथियम न्यूक्लियस इज दिस मच, यू लेस देन द सम ऑफ द मासेस. ठीक है जी, बहुत बढ़िया. ऑफ all the nucleons, the binding energy per nucleon of lithium nucleus is, see binding energy you know that it is given by delta m c square, है ना, or you can write binding energy as delta m into 931 and you get binding energy in mega electron volt. You get the binding energy in mega electron volt, correct? This is what you do, है ना. Fine. Now they are saying that it is 0.042 into 931. ठीक है. Now they are asking binding energy per nucleon, not the binding energy. Binding energy per nucleon. So let us divide it by number of nucleons. How many nucleons are there? 7. So divide it by 7. 10 raised to the power 3 comes here. 776. Solve it. How much you are getting? Solve kara. 0.9, 6 into 0.9 something you would be getting. Now 5.6 mega electron volt. Okay, option number 3. Approximation. Fine, clear? And a binding energy they hadn't asked. Binding energy per nucleon they had asked. Okay, guys? And so 7 se bhi you had to divide. Next. Distance of closest approach they are asking is proportional to. Anji, yes, distance of closest approach. Okay. So they are saying that an alpha nucleus of energy half mv square. How much energy does it possesses? Possesses half mv square. Okay. Bombards with a nuclear target having charge Ze. How much is this charge having? Then the distance of closest approach. So this comes close to it, है ना, ठीक है ना, and this distance becomes r naught, है ना. So how much is this distance? So basically this entire kinetic energy gets converted to the potential energy also. So half mv square is equal to g m1 into m2. सॉरी जी क्यों लिख दिया, के q1 इंटू q2 बाय r नॉट, है ना, डिस्टेंस ऑफ क्लोजेस्ट अप्रोच. ठीक है. तो दे आर आस्किंग द डिस्टेंस ऑफ क्लोजेस्ट अप्रोच, r नॉट गोज हियर, m गोज हियर, ये तो इनवर्सली प्रोपोर्शनल टू m आ जाए. ये भी नहीं आने वाला. ठीक है. Which of the following statement is false, है ना. तो you have to figure out the false statement, है ना. हाँ, false statement. Yes, try it out. False statement. जल्दी जल्दी जल्दी. ठीक है. Oh, it's already across dinner time and now I'm feeling hungry. ठीक है. तो false statement क्या है? Resistivity decreases for semiconductors, है ना. This is a true statement. ये true है. When pure silicon are dropped with trivalent, it generates p-type because more holes are there. At the same time, in p-type, electrons are minority charge carriers. So this is also true. Majority charge carriers in n-type semiconductor are whole. This is false. So this will be your correct answer. False ही पूछा था. Fine. To get output y is equal to 1 from the circuit shown below, the input must be. So this is very simple. A, B and C. These are the three inputs. Your final answer output should be 1. So let us try. Let us send 1 from here, 0 from here and 0 from here. Either this is OR and this is AND gate, है ना. So even if one of them would be there, so it will pass, है ना. AND gate says both of them should be 1. Only then I will let you pass. Otherwise, no. So it will yield 0. So this is not my correct answer. So 1, 0 you had tried. There is no point in trying 0, 1 because it will yield the same. Let us try 0, 0, 1. है ना. Either should be there, otherwise it will not let you pass. Oh, एक second. At least one should be there. है ना. So 0, 1 both should be there, otherwise it will not let you pass. है ना. Okay, so this is omitted. Last option 1, 0, 1. So even if one of it is there, it will pass and will yield you output 1. Okay, option number 4. Fine, clear guys? Okay, so mains question we had already discussed guys. Next session would be on Thursday. Not tomorrow, Thursday at the same timing 8:30 p.m. IST, Indian Standard Timings. The Gulf kids, please mark the date and mark the time. That is day after tomorrow. And trust me, it is gonna be a fun session. Okay, है ना. And अच्छा एक क्वेश्चन और कर लेते जाते जाते, मुझे याद आ रहा है, पता नहीं क्यों. Okay, monatomic gas or having this much pressure and volume is compressed adiabatically to 1/8 of its volume. Then the final pressure is P1 V1 raised to the power gamma, P2 V2 raised to the power gamma. V1 by V2 raised to the power gamma is equal to P2. What is the final pressure? What is the final pressure? है ना? It's a monatomic gas, and gamma for a monatomic gas 1 plus 2 by F. Degree of freedom is 3. So simply you should have written 5 by 3 directly. P1 is P1 only. To 1/8 of its original volume, है ना. V1 was original volume, 1/8 of V1, 5 by 3, P2. V1 gets cancelled out. P 8 raised to the power 5 by 3 is equal to P2. This is 2 raised to the power 3, 5 raised to the power 3, है ना, P2. 3 and 3 gets cancelled out. 2 raised to the power 5, P2. 2 to 4, 4 to 8, 8 to 16, 16 to 32. 32 times P1 is equal to P2. Option number 4. Clear? Any doubt, any query? Class चल रही है ना भाई? Fine. Okay. Great. और भी कर सकते हैं वैसे तो क्वेश्चन, बट ठीक है. Alright, so meet you on Thursday. Thank you very much for choosing Physics Wallah. Please drop your comment section and any feedback you want, that you need the session to be fast. Honestly, I had covered within the time frame pre-questions, mains questions, है ना. ठीक है. I thought it would be of around 3 hours, but yeah, luckily it didn't. Crossed 2 hours 45 minutes. Thank you very much for choosing Physics Wallah, and we will be meeting in the next class. Make sure you subscribe this channel for more updates and share the link with your friends, and see you. All the best.